This is not an ordinary landing. This is an offset landing test, and the pilot should correct for the offset just before crossing the threshold and land safely. It happened that the pilot elected to go around, and he did it perfectly, very close to the ground, uneventfully. Despite of being an extreme flight test maneuver, it bears some interesting lessons very applicable to airline operations. A go-around was very likely as a result of the planned unstable approach, and so the crew briefed the maneuver in its very details. Task sharing and CRM were discussed, and all crew members performed in a timely manner.
Goaround is a safety procedure with a strong reputation of reducing the aviation accident rates. When timely and properly performed, it can reduce runways overruns and mid-air collisions, and provide evasive escape from bad weather.
Minimums.
However, it has been practiced more frequently in simulator sessions, often with an engine failure and from the minimums, in the absence of a real ATC environment. This is not exactly the case of a real-life go-around, where the aircraft's light weight, the high thrust from the engines, the altitude from which the real procedure is flown, and the ATC interference puts the crew into a situation that is not regularly trained. It can add some workload, enough to surprise and disturb the crew to change their plans during a go-around. Statistically, short-haul pilots should experience one go-around every year. Long-haul pilots will go around just once every 2 or 3 years. But depending on the airline, it may surprisingly reach one go-around every 5 or 10 years. Being such a rare procedure, it is essential that pilots be familiar and confident with all aspects regarding the go-around maneuver. This video will focus on ensuring the maneuver is flown safely and effectively, while making crews aware of the difficulties that can occur.
Because the go-around is not a frequent occurrence, being prepared to abandon the approach is a key player in conducting a safe maneuver.
Being prepared means knowledge of briefings, call-outs, sequence of actions, and task sharing. After the decision to abandon the approach is taken, fly the published SOP procedure. Programming the approach into the FMS is part of the landing operation. This includes the go-around as well. The go-around is normally briefed during the descent preparation and should give crews a clear picture why and when the go-around will be performed and who will perform the actions in the procedure. This is a key factor for getting confident to take the decision to abandon the approach at any condition that renders the landing unsafe. At the end of the briefing, crews should have a perfect idea of the call-outs, task sharing, sequence of action, and cross-checks. Some crews take care to do a short briefing during the final approach to recall the key go-around points, and thus enhance its performance. Whether or not there is a short briefing, the importance of being go-around prepared must be emphasized. Why and when a go-around should be performed is dictated by the circumstances, whenever the crew considers that the safety of the landing is or seems to be compromised. The main factors triggering a go-around are meteorological conditions, conduct of the flight, and due to ATC. On the other hand, many accidents have resulted as a consequence of crews failing to decide to go around when the situation required so. Convective weather with degraded visibility, wind, and runway braking action are associated with most of these cases. Pilot professional judgment and airmanship is required to execute a perfect automatic maneuver. During the approach, after the flap is extended one position and the gear is down, the go-around thrust mode is enunciated on the ICAS and FMA, and the FADEC is ready to command go-around thrust as required. Even if the pilot flying or the pilot monitoring has called out or initiated the maneuver, a loud and clear go-around should be heard. According to the SOP, during the final approach, the pilot flying will be hand-flying the aircraft or supervising the autopilot operation and being ready to take manual control while looking outside for acquiring and calling the visual references. The pilot monitoring will be scanning inside and backing up the pilot flying, calling out flight parameters and deviations. At minimums, if no visual reference is established, or a visual contact is established at an inadequate position for a safe landing, the pilot flying will call out go-around. The standard go-around is initiated by pressing either toga button. The thrust levers will move automatically to the toga position. At the same time, the pilot flying verifies autopilot rotating towards the H-degree initial pitch. When the airspeed is greater than VREF, it is time to call out the go-around flaps. The pilot monitoring retracts the slat flaps according to the pilot flying call. Crew coordination is required for both pilots to verify that correct flaps are selected. Autopilot is initially engaged, tracking the go-around mode in the flight guidance system. Check the proper FMA ICAS enunciation modes. Go-around or go-around reserve for thrust. Track is lateral mode, and go-around for vertical guidance. Track mode is used to intercept and maintain an inertial-derived airplane track from the IRS. The guidance will transition from the H-degree initial pitch to the VREF plus 20 knots, all engines, or VAC, single engine, when sufficient speed has been attained. When positive rate is reached, the pilot monitoring, calling out positive rate, will be responded by gear up. With the aircraft configured for go-around, the pilot monitoring will select VFS on the guidance panel and advise ATC. Check the gear is retracting and then confirm a few seconds later that the gear is fully up. At 400 feet above ground level, the pilot flying will call out select FMS and heading or nav, while the pilot monitoring will select the appropriate navigation primary source as required, unless the FMS is not the navigation source, and change from track mode to heading or LNAV, according to the missed approach profile or ATC instruction. At 1,000 feet above ground level, the pilot flying will call for the climb sequence. The pilot monitoring will select VNAV and FMS speeds and retract the flaps on schedule till the point he will call out flaps 0. When the flap handle is selected up, the go-around thrust will change to climb.
Think rate. Think rate. Think rate.
To initiate a manual go-around, the pilot flying presses the toga button and advances the thrust levers to the toga position. The pilot flying asks for go-around flaps, verifies FMA enunciations, track and go-around, and rotates smoothly to follow the flight director guidance to the go-around attitude, which will be 8 degrees for a short period. With a positive rate, the pilot flying asks for landing gear up and follows the flight director that transitions from 8 degrees of pitch to a target speed of VREF plus 20 knots. After the gear up, the pilot monitoring sets VFS at 400 feet, and the pilot flying requests FMS and heading, or nav mode, to proceed with a lateral profile trajectory. At 1,000 feet above ground level, or obstacle clearance altitude, whichever is higher, accelerates to flap retraction speed by selecting VNAV and FMS speed. As airspeed increases, the pilot monitoring retracts the flaps according to the F-bug. With flaps 0, it is time to complete the after takeoff checklist. Considering the rapid changes in configuration and the various manual inputs to cope with the situation, interactions with the ATC, meteorological conditions, or any other factors affecting the normal procedures, coordinated actions and teamwork can help in making go-around maneuvers result in the intended procedure.
Simply stated, the pilot flying should fly the aircraft, supervising the autopilot vertical and lateral guidance and autothrottle operation, or manually flying with the flight director guidance. The pilot monitoring should monitor closely the pitch, airspeed, vertical speed, FMA status and changes, and call out any deviation.
The pilot monitoring should also conduct autopilot and FMS changes as requested by the pilot flying. The pilot monitoring also flies the aircraft mentally, thinking ahead of the aircraft. If he suspects or finds something that could affect the flight, he should notify the pilot flying. Sometimes, when all engines are operating, full toga thrust is not required. If maximum thrust is applied to a lightweight aircraft, it may result in an excess energy situation and probably speed and altitude burst. The alternative procedure to the standard go-around, which is also suitable for high-altitude procedures, is the discontinued approach. Adjust and/or verify altitude preselector. Select the most appropriate vertical mode, FPA, VS, or Felch. Select FMS if it is not the navigation source and select heading, nav, to comply with ATC instructions or to follow the missed approach profile. Resume proper airplane configuration, gear, flaps, and speed as desired.